Welcome everybody to Kweku Online Study. Today we want to talk about implicit differentiation. So this is for Pure Maths 3. It's one of the popular topics that come every year. So we first start with implicit, then the next video I'll shoot parametric differentiation, okay? All right. Now for implicit differentiation, we just have to keep one thing in mind, okay? We already know this, but I want to mention it again. From your study of differentiation, suppose you are given x squared plus 1 to differentiate, and you write dy dx is equal to 2x, right? Now, you have done something. You have differentiated your y and you got dy dx, and you differentiated the x and you got 2x. So this tells us that every time you differentiate y, the answer is dy dx, okay? So if you have y to the power 4, to differentiate only y to the power 4, okay? This is 4y to the power 3, and then you attach dy dx to it. And this happens all the time because it was y that you differentiated. So whenever you differentiate y, you end with dy dx, okay? You might ask, but where is dy dx? Why are we including the x? But there is no x here, but well, there's an x. Actually, this is x to the power 0. Okay, so there is an x. So you always bring dy dx. And most of implicit differentiation, they'll be telling you to show this or do that or do that. Okay, so now we can start doing the question. And one more thing before we do implicit differentiation. Well, this is basically about, when we talk about implicit differentiation, it's about a case where you cannot make y the subject, okay? You cannot make y the subject, okay? If you cannot make y the subject, then what you are dealing with is what we call an implicit function. Implicit function. So this is a case where y cannot stand alone, but they still want us to find dy dx, okay? So this is an example of that. Because if I tell you to make y the subject right now, you are going to find it very difficult to do so. Hence, this is an implicit function, and we are coming to apply differentiation to it, so we call it an implicit differentiation. Now that we have recapped all that we need, we can start the business. All right, so we've been given x cubed plus 3x squared y minus y cubed is equal to 0. So we differentiate x, we are going to get 3x squared. Then with this part, we want to apply product rule because you have two functions. You have x squared and you have y that you are going to differentiate. So let's differentiate the x first. That will be 6xy plus. Now we keep the 3x squared and we differentiate the y, and that will become dy dx. Then we differentiate our negative y to the power 3. That's negative 3y squared dy dx. Like I said, anytime, okay, this guy is equal to 3. And the differential of 3 is 0. Anytime you differentiate y, you have to end with dy dx, okay? Anytime. So now we just group like terms. So I'm going to factor dy dx out. That would give me, hold on. Per how they want us to prove this, if you check the numerator, it's all positive. That means that we need to keep 3x squared plus 6x here, and then we need to move the dy dx to the other side, okay? We are just basically grouping like terms. So we have our 3x squared dy dx minus 3y squared dy dx. So now we can factor 3x squared, factor the dy dx out, and this is what we have. And we can see that dy dx is going to be 3x squared plus 6xy out of 3x squared minus 3y squared. Oh, okay. Actually, this is a mistake because when we move, this is a huge mistake I made. When we move these things to the right hand side, this is supposed to be negative, this is supposed to be positive. So this is negative, this is positive. Therefore, let me write it this way, 3y squared minus 3x squared. Okay. So if I divide 3 by 3, okay, I factor 3 out and I divide, I'm going to have something like this. And that's exactly what they wanted us to prove. Okay, I like proof questions. If it wasn't for a proof, this question being a proof, I would have made a mistake because I forgot to negate when I moved it across the equal to sign. But because I knew where I was going, I could correct that. Okay, so this is it, and this will give us 4 marks, which is cool. Normally the A part is always like this. You don't have to try and figure things out that much. You're just proving it. The B part though, once we understand it, it is always easier. Normally they would tell us parallel to the x-axis or parallel to the y-axis. Okay, so you want to be very, very conversant with both, but we are going to explain, so don't worry about it. The question tells us to find the coordinate of the points. Okay, coordinate of the points where the tangent is parallel to the x-axis. So if you don't know what happens when a tangent is parallel to the x-axis, try and draw something here. Suppose you have x-axis, you have y-axis, and you have a line parallel to the x-axis, right? So suppose you have 2 points on this line. Let's say this is 1. This has a y value of maybe 2, and this is another point. Let's say this is 3. So we have the point 1, 2, and we have the point 3, 2, right? Now, try finding the gradient of this line. So you have 2 minus 2 over 3 minus 1, giving yourself 0 over 2. So that means that the numerator of the gradient function, of the gradient must be 0, right? Okay, so what was your gradient? Well, dy dx was this. So bring it here. So we know dy dx is equal to x squared plus 2x. So x squared plus 2xy over y squared minus x squared. Let me check if that's true. Yep, it is. Okay, so what this means basically is that we know that for the gradient, when it is parallel to the x-axis, means the numerator is 0. So what we are going to do is to take the numerator. So this implies that this numerator is equal to 0. Now, chances are, this is how you are going to do it. You are going to say that, okay, so let me say one thing before. You have to make either x or y the subject, okay? The one that is easier to do. And this is what you are going to do. And you are going to lose marks here. So don't do it. You are going to argue that, well, you have 2xy is equal to negative x squared, and then you divide both sides by 2x, and you are going to write negative x over 2. This is what you are going to write. And it is wrong because, see, when you are solving an equation, do not divide the functions. Don't, because you lose some of the answers, okay? Now, this will feature in the work. However, you lose some too. So what I expect you to rather do is you factor x out here. Okay, so instead of dividing, we rather factor x out. And we are going to have x is equal to 0 or x plus 2y is equal to 0. Okay, if I choose to make x the subject, I'll get negative 2y. If I made x the subject from here, I'll get 2y equals negative x, and x would have been negative 2y, just like the way I got here. But the point is, where is your x equals 0 here? It's not there. So you lose some marks, and that's what I'm saying, that don't do that. Do not be quick to divide through by something, rather factor, okay? Rather factor, it helps a lot. Okay, so now that we have two cases, so we have when x is 0 and when x is 2y. The point is that this x equals 0 and x equals negative 2y, they were the points at which the tangent to this particular curve was parallel to the y-axis. Therefore, you are going to solve these two equations. Okay, let me call this equation 1, call this equation 2, and the original equation as equation 3. Okay, you are going to solve them. So the original equation was given as x cubed plus 3x squared y, and then minus y cubed equals 3. Minus y cubed equals 3. So you're going to solve this simultaneously with this. We can call this equation 3, okay? But the point is you do it one by one. So let's start with equation 1. So we argue that when x equals 0, then this is what we are going to have. We are going to have 0 cubed plus 0 here minus this equals to 3. So we have y cubed equals negative 3, and we take the cubic root of negative 3. If we get a decimal, I'm not going to use it. I'm just going to keep it as it is. Yeah, we get a decimal, so I'll just keep it like this. That means that we have a case when x is 0, we expect y to be this. Now, the next is when, so we are using equation 2. So when x equals negative 2y, we dump it into the equation, the main equation. So we have negative 2y cubed plus 3x squared times the y minus y cubed is equal to 3. And this would be negative 8y cubed minus 6. Hold on, no. I made a mistake in the substitution. It's supposed to be wherever I see x, I put this there. So that's negative 2y squared times y. So that'll be negative 6. So 4 and 12. So positive 12 y cubed minus y cubed equal to 3. And this will give us 3, because that's a negative 9. 12 minus 9 is 3. This equals that. Y cubed is equal to 1. Cubic root of 1 is 1. Now, we know that when y is 1, then your x would be negative 2. So the next point is negative 2, 1. Now, the question said that we should find the coordinates, not coordinate, coordinates. So we're expecting 2 points or more. And where the tangent is parallel to the y-axis, and indeed we got 2 points. So this is one of the coordinates where the tangent was parallel to the y-axis, and this is the other coordinate where the tangent was parallel to the y-axis, okay? So this is that. So this will give you 9 marks, 4 here, and then 5 here. All right, next question. We are told that we should show. Like I said, I like show, because when you make a mistake, it's easier to fix it. So we have y e 2x minus y squared ex equals 2. So now we start by, I will differentiate the e first, so I'll get 2e2xy plus. Now I'm going to keep this and differentiate the y, and that'll be dy dx. Minus, now this part, I don't want you to make a mistake, so my advice is differentiate this in a bracket. So minus, now bring this and differentiate that. If I differentiate the e, I'll get still e to the power x y squared. Plus, now I'm going to keep the e to the power x and differentiate the y squared. You are going to get 2y, include the dy dx to it. Yes, because every time you differentiate y, get dy dx is equal to 0. And now I have 2y e to the power 2x plus e to the power 2x dy dx. Expand this bracket, you get negative y squared e to the power x minus 2y e to the power x dy dx equal to 0. Okay, now look at the numerator. Always look at the numerator. It helps you to know how to move things across the equal to sign. The numerator, we have this guy there nicely, and we have this guy also there nicely. So that means that we want to rather move our dy dx to the other side, okay? So we keep this there, and we keep this, and we move our dy dx. So this is positive 2y e to the power x dy dx. Then I'll have minus e to the power 2x dy dx, okay? So what I did was to move this to the other side and move this to the other side. So now we have 2y e to the power 2x minus y squared e to the power x. And I'm going to factor this dy dx out, leaving me with this guy. So my dy dx must be 2y e to the power 2x minus y squared e to the power x all over 2y e to the power x minus e to the power 2x. And if you look at what we want to prove, you do not see any e to the power 2x there. So that means we need to do further simplification. All right, so we factor e to the power x here. That leaves us with 2y e to the power x. This is the case because if you try and multiply, you get 2y, then you add the power. So you have x plus x, that'll be 2x, okay? So be careful with your factorization, and this will become y squared. The down part too, we factor this out, and we get 2y minus e to the power x. These two will cancel. Therefore, our dy dx is now e to the power y, 2y e to the power x minus y squared all over 2y minus e to the power x. And is that what they wanted us to get? Yep, they wanted us to get this, and we got exactly that. So we're good. And this is it 4? Yeah, 4 marks. Right. So that's how it's done. Take your time, differentiate it, check where you are going. If you have to simplify further, you simplify further. Okay? And then you'll be fine. All right. Now the next thing is we should find the coordinates. Okay. Where's my highlighter? My coordinate, exact coordinates. So we don't want any decimals, okay? Where the tangent is parallel to the y-axis. The first one we did was parallel to the x-axis. This is parallel to the y-axis. So the point is that the denominator must be equated to 0. The denominator of your dy dx must be equal to 0. But, what if you forget in the exam room and you have to prove it? Don't worry, you can easily prove it. Get your x and y axis, get a line that is parallel to the y-axis, and put a point on it. Maybe this is 3, and we have this point, this is 2, so this is 3, 2, and maybe you have this point which is 5, so you have 3, 5. Try finding the gradient. So that's 5 minus 2 over 3 minus 3, you get 3 over 0. So as you can see, the denominator must be what? 0. So if the denominator must be 0, then that means that you want to equate the denominator of your dy dx to 0. Okay, so that's what we are going to do. And this is our dy dx. Let's copy it and then bring it right here. Okay, so nicely. Now, we are arguing that the denominator must be 0. Now, it's up to you. Do you want to make x the subject or you want to make y the subject? Basically, do you, okay? I'll probably make y the subject because it is easier to do so. So this is what I have. Now, this can be equation 1, and the main equation, this one that they gave us, this is going to be your equation 2. Okay, so you are going to solve it simultaneously. Basically, that's what you are doing. Okay, so basically we are going to substitute. So wherever we see y, we are going to put e to the power x over 2. So this will become e to the power x over 2 times e to the power 2x. And you have minus y squared. So this over 2 squared times this is equal to 2. And this will become e to the power 3x over 2 minus e to the power 2x over 4 times this equal to 2, giving you e to the power this over 2 minus e to the power 3x over 4 equal to 2. Multiply 3 by 4 so that I can get 2 e to the power 3x minus this is equal to 8. And you can have this is equal to 8. Take the natural log of both sides, and that will give you 3x equals natural log of 8. Now, because 8 is the same as 2 to the power 3, and I'm seeing a 3 here, I feel like I can just cancel out. So I'm going to do this is ln 2 cube, which is x equals 3 ln 2. So x must be ln 2. Okay. Yes, I know some of you are just going to leave your answer as ln 8 over 3. Yeah, chances are that's what you are going to do as students. But as a math student who is proud to do A-level maths, come on, simplify it. It would be nice, simplify it, please. Would they give you the mark? Probably. I mean, I don't think they're going to penalize you for that. But I also feel that since you take pride in yourself as a math student, just do the right thing, okay? All right, so we want y. So when x equals ln 2, was it y? No, yeah, when x equals ln 2, this is from equation 1, we can find y. So we know y is right here, e to the power x over 2. So we have e to the power ln 2 over 2. And e to the power ln 2 is 2. So 2 over 2 is 1. Therefore, our point where the tangent was parallel to the y-axis is ln 2 and 1. So that's right there with that. So as you can see, these questions are easy and they come every year. They come like that. If you don't see implicit differentiation, you are going to see parametric differentiation. So it's really good that it's an easy topic that we are doing, and it's going to give you free marks basically. So just keep practicing, okay? And I'll put the worksheet in the description so that you can also download it and give it an attempt. All right, so we look at this question. Which year was that? 2019. Good. And it's about 7 months. Whoa. But I promise, they are never difficult. Never. So it doesn't even matter that it is 7 marks. We can still do it. But let's get the key points out of it. So they gave us this equation, and they said that A is a positive constant. We should show that there's only one point on the curve at which the tangent is parallel to what? The x-axis. When we show that there's only one point, we should go ahead and find the y-coordinate of that point. Okay, so we already know what parallel to the x-axis mean to us. We did that right here. And we argue that if it is parallel to the x-axis, the numerator of the dy dx must be 0. So we would apply that. Okay. So we just know that our dy dx, the numerator must be 0. Okay. The numerator of it must be 0. So it's over something, but we don't care. The numerator must be 0. Okay. So we have 2x squared y minus x y squared equals a cubed. So we differentiate. I'll first differentiate the x. That'll give us 4xy. Plus, now I'll keep the x and differentiate the y. I'll get dy dx. Minus, then into bracket, I'll differentiate the x. I'll get y squared. Plus, now I keep the x and differentiate the y. I get 2y dy dx. You always include the dy dx. Now, the a will not be 3a squared. That it is wrong because a is a constant. If you differentiate a constant, you get 0. Okay? That is where you make the mistake. So don't make that mistake, please. We are better than that. Okay, now we expand. We get negative y squared minus 2xy dy dx equal to 0. And now we would, what do we do? Let's factor dy dx out. So we have 2x squared minus 2xy dy dx equals. And now let's move these guys to the other side, this one and that one. Let's move it to the other side. So when we do that, we will get y squared minus 4xy. And our dy dx would be y squared minus 4xy all over 2x squared minus 2xy. Like we said, the numerator must be equal to 0. So we know that y squared minus 4xy is equal to 0. Don't divide through by y. Don't. Just factor y out. So you have this is equal to 0. Okay. And so we know y is equal to 0, or y minus 4x is equal to 0. So y is equal to 4x. So we have two equations that we are about to work with, the main equation. But then the question says, show that there's only one what? Right here. It says, show that there's only one point on the curve. So one of them, either this or that, will be rejected. We don't know which, but let's see. If we accept both, then we are wrong because we want to argue that only one point. Okay. Now, let's copy this guy, the main equation, because we are going to solve it simultaneously with it. Oh no, come back. Copy, and then let's paste it right here. Okay, so let's start with when y equals 0. So when y equal to 0, we shall get this is 0 minus 0 is equal to a cubed, and a cubed equal to 0, a must be 0, and this is rejected. Why is it rejected? Well, because the question told us that a is a positive constant and 0 is a neutral number, neither positive or negative, so it doesn't fit the bill. So sorry, 0, we reject you. So now we are going to work with when y equals 4x. So this will be 2x squared into 4x minus x into 4x all squared equals a to the power 3. And we are going to get 8x cubed minus 4 squared 16x cubed equals a cubed. So this is going to be negative 8x cubed equals a cubed. All right, now let's bring it up. So I can divide both sides by negative 8. So I'll get x cubed equals negative a cubed over 8. Now, you can take the cubic root, and the cubic root of this. You see, I want to show you one thing so I don't jump a step. This is actually a cubed over 2 cubed, which is becoming lengthy, but I know it will help you. You have this, so you have negative into a over 2 all cubed, and your answer is just negative a over 2, because the cubic root will get rid of the cube. Okay. I could have written it from the beginning like that, but I don't want you to ask questions. Why did you do this? Right? Okay. So now they said that what was the argument? We should show that only one of the point is good. Now we have already rejected that a cannot be 0, so it's gone. Okay, a cannot be 0, it's gone. But this fits the bill. This fits the bill, so we're good to go. All right. So we have our x value as this. Now they said we should go ahead to find a y value. So when x equals negative a over 2, y must be 4 into bracket negative a over 2, and y will become negative 2a. And we're done with the question. Okay, so it was that simple. Some of us, we wouldn't reject this one because we will forget that they said a is a positive constant. So we need to read the question carefully so that something that we need to reject, we will reject and we will be good. Okay. Oh, there was so much space, my God, and we had to, crumple everything there. Bad. Okay, so this is different because the B pass says we are going to find 2 points and the gradient of the normal is 1. So it's not like your usual parallel to the x-axis, parallel to the y-axis. But then the proof is always going to be easy. Okay, so we have x squared into brackets x plus 3y minus y cubed equals 3. We should show that dy dx is this. So you may choose to expand it before you differentiate, or you can just differentiate like that. I think expanding it will be easier, right? Yeah. So let's expand, have something like this, and then we can differentiate. So we get 3x squared. I'll differentiate the x, so I get 6x, and I'll keep the y plus. Now I'll keep the 3x squared, differentiate the y, and this will be minus 3y squared dy dx equal to 0. The differential of 3 is 0. Now, if you check the numerator, it is positive x squared plus something, so x squared plus this. That means that the dy dx must go to the other side. So I have my 3x squared plus 6xy equal to 3y squared dy dx minus 3x squared dy dx. So as you can see, we have 3, 6, 3, 3. We can just divide 3 by 3 to simplify things, and that will become x squared plus 2xy equal to y squared minus x squared dy dx. Okay, so I divided 3 by 3. So our dy dx must be x squared plus 2xy over y squared minus x squared. Let's go and check if we are right. Yep, we are more than right. Very, very right. Okay, so we have it. Like I said, these proofs, they are easy to do. Easy to do. Okay, now the next thing that we need to work on is the second part that says that hence find exact value, exact, so we don't want to do anything decimal, exact coordinate of the 2 points on the curve where the gradient of the normal is this. Okay, now let's go and copy the dy dx and come and use it here. Okay, they are telling us that the normal, the gradient of the normal, important, the gradient of the normal is this. So I know my gradient of normal is 1. That means that gradient of tangent must be -1, okay? Because the product of their two gradients should give you -1. Okay, tangent times normal is -1. Now, every dy dx you have, okay, is for the tangent. Every dy dx you have is for the tangent. Of course, I know you can do -1 over this gradient and get the normal and equate it to 1, but I prefer to work with the tangent. That's why I'm making it the tangent way. So I'm rather going to equate my gradient to -1 instead of 1 because I have gotten the, if this is the normal, this is the tangent. So I've converted the question into tangent to do. You can just work it as a normal. All right, so I would cross multiply and I'm going to get -y squared plus x squared. Okay, now as you can see, x squared will cancel x squared and I'm going to have 2xy minus y squared is equal to 0. I do not want to cancel both sides by y because I'll lose some of my answers, okay? And you need 2 answers, 2 points. I keep telling you this because I know it's a mistake you are likely to make, all right? So rather factor y out and you would have something like this. So y is equal to 0 or 2x minus y is equal to 0. So y is equal to 2x. Okay, and you are going to use these two equations to solve simultaneously with the main equation. So let's go and copy the main equation. So the main equation is this. So we copy that and then we come right here and we paste it. Okay, so this is what we have. Do we have more space down there? Nope. So we have to manage it. Okay, so we start with when y is 0, when y equal to 0. We are going to have x cubed minus 0 is equal to 3. So x is the cubic root of 3. So we have the point cubic root of 3, comma 0. Then we do when y equals 2x, we will get x squared plus x into 3 into 2x, okay, minus 2x cubed equals 3. So this is x squared, this is 6x, right? 6x plus that 7x, and minus 8x cubed equal to 3. So that is 7x cubed minus 8x cubed is equal to 3. Negative this equals that. So x cubed equals -3 and x will be the cubic root of -3. So if that is the case, the y value will be 2x, right? So 2 times the whole of this, which will become to become just 2 cubic root of -3. So the next point is cubic root of this, comma, 2 the cubic root of that. And we are done. So they wanted 2 points, and that's what we got. You wouldn't get 2 points if from here you don't solve it well. Okay, the way you do this, if you cancel by y at this point, then you are going to miss one of the points. And you'll be sitting in the exam room wondering why you are wrong, and you wouldn't see it because it's something you always do. Okay, so please do not cancel when you are working an equation. Rather factor so that all your answers will come out. Okay, so yeah, this is it. You should check through. Maybe I've made some plus or minus errors somewhere. Help me out. Great. So this is our last question for the day, I think. Yep. Yes. It's the last question. That's 2022. So we were given this function and they want us to, this is not show, they said find the dx. So this is what I don't like, because if I make a mistake, I wouldn't even know. But then with all of us here on the internet, I'm sure I'm not going to make a mistake. Because if I make a mistake, somebody will definitely put it in the comment section, and it will benefit all of us, isn't it? Yeah. Okay, so this is what I did. I differentiated this, that gives me this. I differentiated that one, and I get this. This is product rule because you have x and y. So I differentiated the x, leaving me with 2y. Now I kept the 2x, differentiated the y. Differentiate 8, you get 0. So that's it. And now I would have 3y squared plus 2x dy dx. I'm factoring dy dx out. Then I'll move this. So I have negative 3x squared minus 2y. And now my dy dx is negative 3x squared minus 2, this all over 3y squared plus 2x. Okay, so this is what we have. The next thing says that there is a tangent to the curve at x equals 0. And then there's also a tangent to the curve at y equals 0. Okay, and these two will meet at an acute angle. So we should find the tan of the angle. So that's fine. We need to bring out our dy dx. We need it. So let's copy it and put it right here. Okay, so we have our dy dx, and we are saying that we should deal with the dy dx when x equal to 0. So we do exactly that. So when x equal to 0, our dy dx, or the tangent, is going to become negative 2y over 2x, right? Oh, no, x is 0, so 3y squared. And if we simplify our gradient function, we get negative 2 over 3y. So this is what we have. And also, we need a y value. So I think that we should just go and find a y value. So let me bring the main function here. If not, the method I was using is going to be a little bit lengthy, and we are not in the mood for that. Okay, so let me start by finding the y. So when x is 0, I have y cubed plus 8 equal to 0. So y cubed is negative 8, and y will be cubic root of negative 8, which is negative 2. So I have the point 0, neg 2, and I can just put it and find my dy dx at once, so that I don't have to find it and later I'm going to find a y and put it in. No. So I have negative 3 into bracket x is 0 minus this into negative 2 all over 3 into negative 2 all squared plus 2 into 0. And that would be 4 over 12, which is 1/3. Okay, do we have more space? Nope. Okay, so when y is equal to 0, remember they also mentioned y is equal to 0. So when y is equal to 0, we put it into the main function, that is this function, to find the x value. And that would be x cubed plus 0, that's the y, plus another 0 plus 8 equal to 0. So I'll get x cubed equals negative this, x must be negative 2. So we have another point, negative 2, 0. So that gradient is going to be dy dx is equal to, remember we have the point negative 2, 0, and we have our gradient right here. So x is negative 2 and y is 0. So we put exactly that into the dy dx, and that will be negative 12 in the numerator over negative 4 in the denominator, giving us 3. Okay, so now to help us do this work very well, I think let's sketch something, because the two tangents are meeting at an acute angle of alpha. So suppose that we have this and that as our x and y axis, and we have two tangents. Let me use two lines, black. So let's say one of the tangent is this, and so the bigger the gradient, the steeper it is, and one tangent is like this. This is going to have a gradient of 3, and this is going to have a gradient of 1/3. Okay, the flatter the line, the smaller its gradient, and the steeper the line, the bigger its gradient. So they are creating an angle of alpha right here. Now, mind you that every gradient is rise gradient. Or let me write it somewhere here so that we erase later on. Every gradient is rise over run. Okay, so if you have a gradient of 3, it means it's 3 over 1, and this one is already 1 over 3, so no problem with that. Now, every gradient or tangent we can extract a right angle triangle from it. So let's say that we have a line parallel to the x-axis right there. So we can form a right angle triangle with this black line, and we can also form a right angle triangle with this red line. Okay, so we want to know what the alpha value will be. Okay, so to find the alpha value, actually they want the tan of the alpha value right here, the tan of the alpha value. So tan alpha, that is what they want. So if they wanted only alpha, then we know this is 1 and the rise is 1 and this is 3, and here will be 3 and this would have been 1. So that would have been super easy for us to just find the angle here. Let me call that beta, and it will be easier for us. Okay, but then there is something that we need to understand, that the whole angle here, let's call the whole angle gamma. We know that gamma is you finding, no. If you want alpha, alpha is finding the entire angle gamma minus the beta. Okay, and the question says we should find tan alpha. And tan alpha is actually the same as saying tan gamma minus beta. So this means that if you have a case like this, go to P3 trigonometry, okay, and apply what we call the compound angle. So let's apply the knowledge of the compound angle. So this means tan gamma minus tan beta all over 1 plus tan gamma tan beta. All right. So we are just applying P3 here. Now, let's first start by looking for tan gamma. Well, tan gamma is basically tan of the entire angle, and the big angle is coming from this triangle formed by the red line. Okay, so tan is opposite over adjacent, so that's 3 over 1, which is 3. Minus tan beta. Now, where is beta? Well, beta is right here, this small one. So this is the triangle in question. So if I'm looking for tan of the angle, then it's just going to be 1 over this, opposite over adjacent. So that's 1 over 3. All over 1 plus 3 times 1 over 3. And this should give us 8 over 3 divided by this and that, so divided by 2. And I think we should get 4 over 3. That's my calculator. Let me see. 8 over 3 divided by 2, and that's 4 over 3. So we are arguing that our tan alpha must be 4 over 3. So that's how we solve questions like this. Is a little bit difficult, I'm not going to lie, because I think working from finding your first gradient, finding your second gradient is not hard at all because you already know how to do that. But trying to visualize it and applying P3 compound angle to it and coming up with this conclusion, yeah, that might be a little hard. But I think once I've done this question with you, if you see a similar question, you would know how to go about it, right? Cool. So this is the end. I would shoot parametric in the next couple of days, maybe 2 days from now or so, or maybe even tomorrow. So you should check out the channel. The worksheet is in the description. You can download it and give it a try. Okay? I'll see you in the next one. Have a good one.